T7.15. In a children's book, the mean word length is 3.7 letters with a standard deviation of 2.1 letters. In a novel aimed at teenagers, the mean word length is 4.3 letters with a standard deviation of 2.5 letters. Both distributions of word length are unimodal and skewed to the right. Independent random samples of 35 words are selected from each book. Let X bar C represent the sample mean word length in the children's book, and let X bar T represent the sample mean word length in the teen novel. All right, so that's a lot of information in that one paragraph, so let's try to summarize. The first sentence here is talking about the population of all words in the children's book. So when they talk about the mean being 3.7, they're really referring to the true mean or the population mean. So we're going to label this mu C, because it's from the children's book, is 3.7. And then that standard deviation is for the entire population, right? So for all words in that book. So we can write sigma C equals 2.1. Okay, same thing with the next sentence, 4.3 and 2.5. That's the mean and standard deviation for all the words in the teen book, right? So those are population values. Okay, so we could write mu T equals 4.3 and sigma T equals 2.5. Okay. Now it's important to note that both of the populations have skewed right distributions, but we're taking random samples of 35. So we can write NC equals 35 and NT equals 35. And that's important, right? Because 35 would be considered sufficiently large, meaning that our sampling distribution will be approximately normal, even though the population distributions are skewed. All right, so let's start with part A. Find the mean of the sampling distribution of X bar C minus X bar T. Trying to do split screen here. It's not wanting me to do that. There we go. All right, so we're looking at the sampling distribution for a difference of two means, right? So we're going to look right here, and we're going to use this formula. Okay, so the mean of this sampling distribution is simply the difference of the population means. Okay, mu1 minus mu2, or in this case, mu C minus mu T. All right, so the mean of X bar C minus X bar T is simply the difference in the population means, mu C minus mu T. So 3.7 minus 4.3, which is negative 0.6. All right, part B. Calculate and interpret the standard deviation of the sampling distribution. Verify that the 10% condition is met. Okay. So 10% condition, it would be confirming that the sample size is less than or equal to 10% of the population. So 35 words is likely less than 10% of all words in the children's book, and same could be said for the teen book. Okay. So it's reasonable that 35 words is less than 10% of all words from either book. In other words, our sample is relatively small compared to the size of the population. Okay. All right, so now we want to calculate the standard deviation. So here's the formula that we're going to use right here on the left. It's that square root expression right there. So the standard deviation of x bar c minus x bar t is the square root of sigma c squared over nc plus sigma t squared over nt. All right, and that's going to be square root 2.1 squared over 35 plus 2.5 squared over 35, and that will be approximately, okay, 0.55. All right, we also want to interpret it. So because it's a standard deviation, we're going to talk about how things typically vary from the mean. Okay. So we can say the difference in the sample means, and we're doing the children's book minus the teen book, typically varies by about 0.55 letters. Yeah, we're talking about word length, so that's the number of letters in a word, by 0.55 letters. The difference in the sample means typically varies by about 0.55 letters from the true mean of negative 0.6. Now the reason why the true mean is negative is because we expect the children's book to have a lower average word length than the teen book. All right, part C. Justify that the shape of the sampling distribution is approximately normal. So I alluded to this earlier. It's the fact that both sample sizes are sufficiently large. The central limit theorem guarantees that the sampling distribution is approximately normal. Since both sample sizes are sufficiently large, 35 is greater than or equal to 30. Central limit theorem guarantees the sampling distribution is approximately normal. All right, so all of this I think was a lead up to part D, where we're now going to calculate a probability. So what's the probability that the sample mean word length is greater in the sample from the children's book than in the teen novel? All right, so because in part C we said the shape's approximately normal, we'll start with that sketch. And because in parts A and B we calculated the mean and standard deviation. So the mean is negative 0.6, standard deviation is about 0.55. Negative 0.6. Okay. All right, so if the sample from the children's book has a larger mean than the teen novel, right, that's saying that C is greater than T. So if C is greater than T, let me just make sure I'm reading this right. What probability is the sample mean word length is greater in the sample from the children's book? Yeah. So if C is greater than T, that means the difference of this would be positive, right? Because the children's book would be larger and the teen value would be smaller, so this would be greater than 0. Okay. So really, part D, if we write it in notation, we want to find the probability that x bar c minus x bar t is greater than 0. All right, now so 0 is our boundary value. And because the mean is negative 0.6, then 0 would be somewhere over here in the right tail, and we're looking for values greater than 0. I'm going to shade that right tail. All right, and now we're just going to use our traditional skills with normal distributions. We're going to standardize, aka find the z-score, and then use table A to get that area. All right, so value minus the mean, so be careful here, you're subtracting a negative, divided by the standard deviation. So that's really positive 0.6 divided by 0.55, 1.09. Okay, and now we'll go to table A and look that up, 1.09, which is right here. 1.8621. Of course, we're going to subtract that from 1 since we're looking for the area in the right tail, so 0.1379, or about 14% if you round.